Good evening, everyone. Today I want to study about the different methods of carriage of liquefied gases and what is reliquefaction of gas and how is it done on gas tankers. So at first I try to focus on different methods of carriage of liquefied gas. The transportation of liquefied gas by sea requires a special containment system to maintain the gas in a liquid state under controlled temperature and pressure. The IGC code, that is International Code for the Construction and Equipment of Ships Carrying Liquefied Gas in Bulk, outlines the approved method for the safe carriage of liquefied gases. These methods are primarily based on how the gas is kept in liquid form, either by pressurization, refrigeration, or a combination of both. Below are the main methods of carriage for liquefied gases are mentioned. Number 1. Fully pressurized carriage. In this method, the gas is carried in a liquid state under high pressure at ambient temperature. No refrigeration is used and the gas is compressed into liquid form by increasing the pressure inside the tank. Key factors for fully pressurized carriage, that is pressure level. The pressure inside the tanks typically ranges from 17 bars to 18 bars. Tank construction. Fully pressurized tanks are built to withstand high pressure and are usually constructed of carbon steel or high strength alloys. Ambient temperature. The cargo is carried at surrounding environmental temperature with no additional cooling system is needed. Advantages. Simplicity. Fully pressurized tanks do not require refrigeration, making them simpler in design and operation. Smaller vessels. Vessels using this method tend to be smaller and are mainly used for short sea voyages or in regions where high pressure infrastructure is available. Typical cargoes: LPG, that is a liquefied petroleum gas, propane, butane. Number 2. Semi-pressurized and refrigerated carriage. This method uses a combination of moderate pressure and partial refrigeration to carry the gas in liquid form. The pressure is lower than fully pressurized systems, but the gas is kept at a lower temperature to minimize vapor pressure. Key features: moderate pressure. The cargo is carried under moderate pressure, typically between 5 bar and 9 bar. Next, partial refrigeration. The cargo is cooled at temperature between minus 10 degree and minus 15 degree Celsius, depending on the type of gas. Next, insulated tanks. The tanks are insulated to prevent heat ingress and maintain the cargo temperature. Main advantages of this carriage are flexibility. This method allows for carriage of wider range of liquefied gases, including those that are not suitable for fully pressurized or fully refrigerated systems. Next, lower pressure. By reducing pressure, the tanks do not need to be as robust, lowering construction costs compared to fully pressurized systems. Suitable cargoes for this carriage is LPG, propylene, ammonia, butadiene, etc. Now, number 3. This method is called fully refrigerated carriage. In fully refrigerated carriage, the gas is carried at atmospheric pressure or very low pressure and kept in a liquid state. Through full refrigeration at extremely low temperature, this method is used for large quantities of liquefied gases. Key features for this system is atmospheric pressure. The cargo is carried at near atmospheric pressure. Low temperatures. The gas is maintained at a temperature near its boiling point under atmospheric pressure. Example: minus 104 degrees Celsius for ethylene and minus 50 degrees Celsius for LPG. Next, large tanks. Fully refrigerated vessels can have large tank capacities, allowing them to carry significant quantities of cargo. Main advantages for this method is cost-effective for large volumes. This method is ideal for long voyages and large cargo volumes, as the lower pressure and large tanks reduce transportation cost. Less pressure, more safety. By using lower pressure, the risks associated with high pressure containment are minimized. Typical cargoes: LPG, ammonia, ethylene, butane. Number 4. Ethylene carriers. Ethylene carriers are specialized gas carriers designed to transport ethylene at temperature below its boiling points, that is minus 104 degrees Celsius and atmospheric pressure. Key features: low temperature. Ethylene is kept in liquid form at minus 104 degrees Celsius, which requires advanced refrigeration system. Insulated tanks. The tanks are heavily insulated to maintain the low temperature and minimize heat transfer from the surrounding environment. Pressurization. Ethylene carriers also have the ability to pressurize the cargo slightly to prevent vaporization during loading and unloading operations. Advantages: specific use. Ethylene carriers are designed to handle the unique properties of ethylene, which cannot be transported using standard gas carriers. Typical cargo is only ethylene. Number 5. Liquefied natural gas, that is LNG carriers. LNG carriers transport liquefied natural gas at atmospheric pressure and extremely low temperature, that is minus 162 degrees Celsius. This method uses advanced refrigeration and insulation systems to keep the gas in a liquid state. Key features: atmospheric pressure. The LNG is carried at or near atmospheric pressure. Ultra low temperature. LNG must be kept at minus 162 degrees Celsius to remain in liquid form. Specialization tanks. LNG carriers typically uses the membrane tanks or moss-type spherical tanks to contain the LNG and prevent heat ingress. Boil of gas measurement. LNG carriers are designed to handle boil of gas, which is vaporized LNG that results from slight heat ingress. This gas is either liquefied or used as fuel for the ship's propulsion. Advantages: large volume. LNG carriers are designed to carry large quantities of gas over long distance. Efficiency: LNG can be transported more efficiently in liquid form due to the lower volume compared to its gaseous state. Typical cargo: LNG, that is methane, ethane, etc. Number 6. Compressed natural gas, CNG carriers. Compressed natural gas is transported at high pressure around 200 bars to 250 bar in large cylindrical tanks. CNG carriers is less common than LNG due to its limitations in cargo volume and transport efficiency. Key features for CNG carriers: high pressure. The gas is carried at a very high pressure in specially designed cylinder or spherical pressure valves. Ambient temperature. No refrigeration is used and the gas is carried at ambient temperature. Smaller vessels. CNG vessels are typically smaller than LNG carriers due to the high pressure requirements. Advantages: no refrigeration. CNG carriers does not require the complex refrigeration system needed for LNG. Simpler infrastructure. Loading and unloading infrastructure for CNG is simpler compared to LNG. Typical cargo: natural gas, that is methane. Reliquefaction of gas. Reliquefaction is the process of turning vaporized gas back into its liquid form. On gas tankers, particularly those carrying liquefied gases like LNG or LPG or any gas as a small amount of liquid cargo naturally evaporates due to heat ingress. This process is known as boil off. To prevent the build-up of pressure in the cargo tanks and to minimize cargo loss, vaporized gas is re-liquefied and returned to the cargo tanks in liquid form. Reaction is critical for maintaining the cargo in a stable condition throughout the voyage and ensuring the vessel operates safely by preventing dangerous overpressurization of cargo tanks. Procedure of reliquefaction on gas tankers. Reliquefaction process for different gases. LNG carriers. LNG is carried at very low temperature around minus 162 degrees Celsius and atmospheric pressure due to the extreme temperature difference between the cargo and environment. Boil-off gas is a common occurrence. On LNG carriers, boil-off gas may be handled in two ways, that is, reliquefaction and boil-off gas used as a fuel. First, reliquefaction. The vaporized LNG is compressed and cooled back into liquid form using advanced refrigeration system and in boil-off gas as fuel. Some LNG carriers use boil-off gas as fuel for the ship's engines, reducing the need for the reliquefaction and enhance the fuel efficiency. LPG carriers. LPG is carried at moderate temperatures and pressure. Reliquefaction of LPG vapor is relatively easier compared to LNG due to its less extreme temperature and pressure requirements. The reliquefaction process on LPG carriers involves compressing the vapor and cooling it using seawater or refrigerants in heat exchangers to condense the gas back into liquid form. 3. Types of reliquefaction systems. Partial reliquefaction system, commonly used on LPG carriers. In this system, only part of vaporized gas is reliquefied and returns it to the tank, ensuring no cargo is lost as vapor. It is more energy but ensures maximum cargo retention. Reliquefaction process for different gases. LNG carriers. LNG is carried at very low temperature around minus 162 degrees Celsius and atmospheric pressure due to the extreme temperature difference between the cargo and environment. Boil-off gas is a common occurrence. On LNG carriers, boil-off gas may be handled in two ways, that is, reliquefaction and boil-off gas used as a fuel. First, reliquefaction. The vaporized LNG is compressed and cooled back into liquid form using advanced refrigeration system and in boil-off gas as fuel. Some LNG carriers use boil-off gas as fuel for the ship's engines, reducing the need for the reliquefaction and enhance the fuel efficiency. LPG carriers. LPG is carried at moderate temperatures and pressure. Reliquefaction of LPG vapor is relatively easier compared to LNG due to its less extreme temperature and pressure requirements. The reliquefaction process on LPG carriers involves compressing the vapor and cooling it using seawater or refrigerants in heat exchangers to condense the gas back into liquid form. 3. Types of reliquefaction systems. Partial reliquefaction system, commonly used on LPG carriers. In this system, only part of vaporized gas is reliquefied and returns it to the tank, ensuring no cargo is lost as vapor. It is more energy but ensures maximum cargo retention. Number 4. Safety controls. Pressure control. Reliquefaction systems are crucial for maintaining tank pressure within safe limits. Without re-liquefaction, excessive pressure could build up, leading to dangerous conditions. Temperature control. Efficient re-liquefaction ensures that the cargo is kept at the required low temperatures to remain in liquid form, preventing vapor build-up and maintaining safe operation conditions. Monitoring and automation. Re-liquefaction systems are highly automated and monitored continuously to ensure the system operation efficiently and safely. The system automatically adjusts to changing conditions such as variation in boil-off gas rates. Cooling down of tanks and gas tankers. Cooling down of tanks is a critical process on gas tankers that carry liquefied gases like LNG, LPG. The primary objective of cooling down the cargo tanks is to lower their temperature to a level close to that of the liquefied gas before loading. The process is necessary to minimize thermal stress on the tanks and reduce the rate of boil-off gas during the loading process. Now, why cooling down is necessary? Thermal shock prevention. Liquefied gases are often carried at extremely low temperature, example minus 162 degrees Celsius for LNG. If cargo tanks which are at ambient temperature were to be filled with dry or heavy liquid without cooling down fast, it could cause thermal shock, leading to damage or cracking of the tank structure due to the rapid temperature change. Boil-off gas reduction. When warm cargo tanks come in contact with cold liquefied gases, a large volume of gas will immediately vaporize. That is, boil-off to cool down the tanks. By pre-cooling the tanks, the amount of boil-off gas is significantly reduced, minimizing cargo loss and preventing pressure build-up. Procedure for cooling down tanks. The cooling down of gas tanks involves gradually lowering the temperature of the tank structure by introducing the cold gas in a controlled manner. The process is carried out using boil-off gas or the liquefied gas itself. Number 1. Preparation for cooling down. Tank purging and gas freeing. Before cooling down, the tanks must be purged and gas freed to remove any inert gas such as nitrogen or flue gas that may be been used to inert the tank after a previous discharge. This is crucial to prevent contamination of the cargo. Safety checks. Ensure that all equipment, piping and instrumentation are functioning completely. Verify that the tank pressure and temperature monitoring systems are in place and operational to avoid any risk of overpressurization or freezing. Number 2. Gradual introduction of cold vapor. The cooling down process begins by introducing cold vapor from the cargo, such as boil-off gas, into the tanks. Cold vapor is circulated throughout the tank atmosphere to start lowering the tank atmosphere gradually. Circulation fans. Fans are often used to circulate the cold vapors around the tanks, ensuring uniform cooling of tanks walls. This step is critical to avoid localized cooling, which can cause uneven thermal contraction. Number 3. Introduction of liquefied gas. A small amount of liquid. After the initial cooling with vapor, a small amount of liquefied gas, LNG or LPG, is slowly introducing into the tanks. The liquid vaporizes on contact with the warmer surfaces of the tank, continuing to cool it down. Control rate. The rate of liquid introduction is controlled to ensure a gradual temperature drop. Introducing the liquid too quickly could result in excessive boil-up and overpressurization, which could be dangerous. Number 4. Monitoring temperature and pressure. Continuous monitoring. The temperature and pressure inside the cargo tanks are continuously monitored during the cooling down process. Temperature sensors are placed at different points in the tank to ensure uniform cooling. Pressure control. As the cargo vaporizes during the cooling process, the pressure in the tanks can increase. The boil of gas is tactically managed by the ship's reliquefaction plant, which cools and reliquefies the gas or uses it as fuel for the vessel's propulsion system. Number 5. Completion of cooling down. Once the tank reaches a temperature close to the temperature of the cargo, for example, minus 162 degrees Celsius for the LNG, the tank is considered ready for loading. The tank pressure is then stabilized and the loading process can begin. Challenges during cooling down. Rate of cooling. Challenges during cooling down. Rate of cooling. Cooling down too quickly can cause damage to the tank due to uneven contraction of materials, while cooling too slowly can lead to delays and inefficient operations. Boil off management. Managing the boil of gas efficiently and effectively during cooling is crucial to prevent excessive pressure buildup and cargo loss. On LNG carriers, the boil of gas is often used as fuel for the ship's propulsion system, but any excess gas must be reliquefied for safely maintained. Tank material stress. The rapid cooling of the tank can put stress on the material. The structural integrity of the tank must be maintained to avoid cracks or other failures. Cooling down procedure for different gas carriers. LNG cooling down. For LNG, the cooling down is critical due to the extremely low carrier temperature of minus 162 degrees Celsius. LNG tanks are usually pre-cooled using boil of gas. Circulation fans. Fans are often used to circulate the cold vapors around the tanks, ensuring uniform cooling of tanks' walls. This step is critical to avoid localized cooling, which can cause uneven thermal contraction. Number 3. Introduction of liquefied gas. A small amount of liquid. After the initial cooling with vapor, a small amount of liquefied gas, LNG or LPG, is slowly introducing into the tank. The liquid vaporizes on contact with the warmer surfaces of the tank, continuing to cool it down. Controlled rate. The rate of liquid introduction is controlled to ensure a gradual temperature drop. Introducing the liquid too quickly would result in excessive boil-up and overpressurization, which could be dangerous. Number 4. Monitoring temperature and pressure. Continuous monitoring. The temperature and pressure inside the cargo tanks are continuously monitored during the cooling down process. Temperature sensors are placed at different points in the tank to ensure uniform cooling. Pressure control. As the cargo vaporizes during the cooling process, the pressure in the tank can increase. The boil of gas is tactically managed by the ship's reliquefaction plant, which cools and reliquefies the gas or uses it as fuel for the vessel's propulsion system. Number 5. Completion of cooling down. Once the tank reaches a temperature close to the temperature of the cargo, for example, minus 162 degrees Celsius for the LNG, the tank is considered ready for loading. The tank pressure is then stabilized and the loading process can begin.